Can you hear me?
Yes, sir.
Okay, then yeah, we'll carry. Power was not there. No, this is about the. I'm just what it is. It's a circular disc. It's a circular disc. I'm connecting. I'm suspending by a string, a light inextensible string. So now, how that torque and angular acceleration. So I'm just going to spin it. Let's see. So I applied some torque on it, and because of that torque, it is having an angular acceleration alpha and angular velocity omega. Actually, alpha and omega will be upward. These are the sense of rotations. So then how do sir this will rotate? I think this is quite clear, no? So you can apply the tangential force on it and it starts rotating. Then as it starts rotating, let me take a particle here. Let me take a particle at a distance r. This particle will have mass dm and it will have tangential velocity. Then what is v? We are going to write it as r omega. Then it will also experience a tangential acceleration. It will also experience a tangential acceleration. So what is the tangential acceleration? dm into at. Both should be in same direction. No, both will be in same direction. So this is like this. So first, what is v equal to? V equal to r omega. Then what is the tangential force? dft should be equal to dm into at. What is at? So we know from circular motion it should be equal to r alpha, tangential acceleration. So I'm going to substitute that dm into r alpha. Now look at this. Is there any other force acting on this one? Yes, there is another force acting. What is the other force that is acting on system? So centripetal force, dfn, and what is dfn should be equal to? dfn should be equal to dm into an. What is an? You can write omega square r. So this will become dm omega square r. Tell me, like, which force will set up a torque? I think the centripetal force, or what you can call normal force, will intersect axis of rotation, and this is the axis. Will intersect axis of rotation. So therefore, so we'll set up torque only the tangential forces. So the torque set up by tangential forces. Now d tau should be equal to dft into r. And how the tangential force will act? Will act perpendicular. So what is dft? From the formula, this should be equal to dm into r alpha into r, or dm r square into alpha. This on one particle. Like that, different particles of different mass will be at a different radial distance. So what is dm and r? They are variable, no? So therefore, the summation of the net torque should be equal to, and all particles must have same angular velocity. Same angular acceleration? Will I agree? Go back. Kinematics of rigid body motion. If a rigid body rotates, all particles must have same angular velocity, same angular acceleration. Different particles will have different linear velocity, different linear acceleration. So therefore, alpha will be common. So summation of dm into r square. What is summation of dm r square? And this is net torque. So this should be the moment of inertia. Summation of dm r square is what? Moment of inertia. So like that, the net torque equal to angular acceleration about that axis into moment of inertia about that axis. Like this, we'll get the torque equation. And then this is about the simplified way what is given as Verma. I'll show by another method. Vector method also I'll show it, so they'll be easy for you. So now what about the rotational kinetic energy? The disk is rotating. Disk is, there's a string and there's a disk, rotating disk. Now, what is the kinetic energy? I'll proceed in the same way. kinetic energy of that small element of dm into v square. What is v? R omega. Now, omega and all particles will have same angular speed, but different particles will have different masses and different radial distances. Then this is decay. So summation of decay. So now, what is the summation of dm r square? This should be the moment of inertia. So this is the rotational kinetic energy called kr should be equal to omega square I, or I omega square by 2. So like this is a rotational kinetic energy of the disk. Different particles will have different linear velocity, but all particles will have same angular velocity. So we do express rotational kinetic energy by this method. And what about if a torque acts? I think this is nothing but Newton's laws of motion, Newton's rotational laws of motion. What earlier we had F equal to ma for translating, now torque equal to I alpha will be for rotational motion. Okay, this is what in the basic like SE Orma, what he has put it in very simplified way so the students can understand in simplified way. So let me put it in another way, in the vector form. So we know that if a particle like a same in the vector form, how alpha r and a will be, how linear acceleration will be in the vector form. This linear acceleration at bar should be equal to alpha bar cross r bar. Go back to circular motion concept. A tangential should be equal to alpha bar cross r bar. Then what about the net torque? The net torque acting on system should be equal to r bar cross F tangential. Due to that summation of that. And what is DFT? DFT should be equal to, this will be further summation of r bar cross DFT should be equal to dm into at bar. Further expansion of this will be r bar cross dm. What is at bar? At bar should be alpha bar cross r bar. So dm, let me take total outside. So here from the bracket, this is alpha bar cross r bar cross alpha bar cross r bar. Can you go back to vector triple product? Can you go back to the vector concept? So this if I expand, so how much will end up? No, this will be alpha bar r dot r minus, sorry, this one. Yeah. Then there should be r bar dot alpha bar. We know how r bar and alpha bar will be. Sir, on what basis you are saying? We know alpha will be along the string, and how r bar is in this direction. So r bar is perpendicular to, in fact, alpha bar. So therefore, what should be the dot product of this? This should be equal to 0. Summation of so finally, what we end up, this should become equal to summation of dm r square alpha bar. So is it okay? No. So this let me put in systematic way. So this is r bar cross dft bar is equal to alpha bar summation of dm square. This will become net torque, and this will be alpha bar, and this is the moment of inertia. So therefore, the final formula will be F bar equal to ma bar. Similarly here, net torque tau bar is equal to I alpha bar. It should be the vector form. It will be like this. When we do some three-dimensional motion problems tomorrow, when I discuss two-dimensional, three-dimensional problems, we need this vector form. When you're discussing some only one-dimensional problems, then no need of this particular thing. Two-dimensional, yes, I need this particular formula. That's why I just brought in the vector form also. Just remember the theoretical, because directly if I write tau bar equal to I alpha bar, then you'll get confused. That's why in the SORMA, this is what given. So this will help us lot in when we go for two-dimensional problem. Okay, next question comes after this. What are the conditions? So why you are taking torque equal to about the center of the disk only? Why not about any other point? So the very first best question is what you can ask for teacher. So about what point you define torque? About the string or about the axis of rotation. So why you are defining about that point only? Why not about any other point? You can define about any point, but you can't write, you can't simplify. You don't end up with a simplified equation. That's why the torque is defined about the axis of rotation. So it's a very simple, about which point the rigid body is rotating. About that point you define torque, but still, sir, like a because it's my choice. You can put like this. So it's my choice. Why you define torque about O? I will define some other point P somewhere here. I'll define about this point. Yes, you can define, but you don't end up with mathematical equation. So what is a common practice? Define torque about axis, about an axis about which it is rotating, so that what happen, you will end up with a simplified equation and you can solve, you will get answer. So the question what that is, I'll put that question itself. So let me take a the disk. So this is a disk now. This is the axis O. So let me take about some arbitrary point P. In fact, what will happen?